In this video, we are going to talk about isotopes and how atoms of the same element can actually be different from each other. But first, it's really important to understand that all atoms of the same element have the same number of protons. This is what identifies an atom of a specific element, by how many protons it has. So all hydrogen atoms have one proton. That's what makes hydrogen hydrogen. But atoms of the same element can have different numbers of neutrons. There are hydrogen atoms with no neutrons. There are hydrogen atoms with one neutron. There are even hydrogen atoms with two neutrons. So you can have different numbers of neutrons in an atom of the same element. So atoms with the same number of protons but different numbers of neutrons are called isotopes. And you may recall that protons have a mass of 1 and neutrons have a mass of 1. So atoms of the same element can actually have different masses because if they have different numbers of neutrons. So how do we identify isotopes? Well, the same way you would identify atoms. We use the element symbol. Now there's some extra notation that goes with identifying different isotopes if that's what you're trying to communicate. And one part of that notation is by using a subscript before the element symbol. That subscript contains the atomic number, or the number of protons. Now this might seem a little redundant because all atoms of hydrogen will have the same number of protons. So they'll all have the same number before it in that subscript. But if we use the top number as well, which is the mass number, we can separate or distinguish the different isotopes of hydrogen. That top number represents the mass number. And if you remember, the mass number is the number of protons plus the number of neutrons. So we can have hydrogen with a mass number of 1, which means it has 0 neutrons. We can have hydrogen with a mass number of 2, which means it has 1 neutron and 1 proton, of course. And we can have hydrogen with a mass number of 3, which means that it has 1 proton, because hydrogen always has 1 proton, and 2 neutrons. So this is a really, really heavy version of hydrogen. Another way we can represent different isotopes, and this is a less symbolic way, is by writing the name of the element followed by a hyphen, and then followed by the mass number. So our different isotopes of hydrogen would be hydrogen 1, hydrogen 2, and hydrogen 3. This is often what's used as the way of representing different isotopes when radioactivity is the topic. So let's take a look at 3 different isotopes of carbon. So here we have isotope 1. This is carbon 12. And you'll notice that this carbon, of course, has 6 protons. All atoms of carbon have 6 protons. So this is carbon with 6 protons, of course. It has 6 electrons because it's neutral, same number of positives versus negatives. And this specific isotope of carbon has 6 neutrons. So we would represent that using the chemical symbol C. And then before that, we would put a subscript 6, which represents the atomic number. Now, anytime you have C as your element symbol and you do this notation, you're going to have a subscript of 6 because that is your atomic number. That's what identifies carbon as carbon. It has 6 protons. So you're always going to have that 6 down there. And then the superscript before the C is going to have the number 12, which is the number of protons plus the number of neutrons. It's our mass number. This is carbon 12. Now let's take a look at carbon 13. Our element symbol is C, and we're going to have the subscript 6 before it because carbon always has 6 protons. And then our superscript is going to be 13 because we have 6 protons and 7 neutrons. So 6 plus 7, mass number, it's the number of protons plus the number of neutrons. 6 plus 7 is 13. Here we have one final example, and this is carbon 14. So of course we have our element symbol C with the subscript 6 before it, indicating the atomic number, and our superscript before the C is going to be 14. We have 6 protons and 8 neutrons. This is a much heavier version of carbon. If you look, this one is a radioactive isotope of carbon. The other two that we talked about were stable and not radioactive. This third one is a radioactive isotope of carbon. This is the isotope that is used in radioactive carbon dating. So this specific isotope is what scientists are interested in when they date an old artifact. Let's try some practice problems. So how many protons, neutrons, and electrons are present in each of the following atoms? So here we have some chlorine, and the subscript is 17, the superscript is 35. Now the number of protons is going to be 17. That's what's given in that subscript, that atomic number, the number of protons is 17. It's always going to be 17 for chlorine. Now the number of neutrons is where it varies. So this specific isotope of chlorine has a mass number of 35. So the number of protons, which is 17, plus the number of neutrons will equal 35. So to figure out how many neutrons, we take 35 minus 17, just a little bit of algebra there. So 35 minus 17 will give us our number of neutrons. And we get 18, if you type it into a calculator, we get 18 neutrons in this specific isotope of chlorine. The number of electrons in this isotope is going to be the same as the number of protons. So if it has 17 protons, it will have 17 electrons because this is a neutral atom of chlorine. So 17 protons, 18 neutrons, and 17 electrons. Now I want you to try this one on your own. Pause the video, see if you can try it. The number of protons, this should be easy, in this krypton isotope is 36. So we have 36 protons. All atoms of krypton will have 36 protons, will have an atomic number of 36, so that bottom subscript should be 36. Now the mass number of this isotope is 84, which means that the number of neutrons has to be 48. How did we get that? We took 84 minus 36. So the mass number minus the atomic number gives us our number of neutrons. And of course, there are 36 electrons in this specific isotope of krypton because this one is neutral and it has an atomic number of 36.